Okay, welcome everybody. Today we're going to go ahead and start chapter 2. Section 2.1 is quadratic functions and their models. So this is lesson number 12. Last night I had asked you to watch a brief introduction video to chapter 2 just to kind of set the scene, not only for what we're going to do today, but what we're going to kind of investigate during this entire chapter. So last night you kind of went through the different forms of the quadratic, standard, vertex, and factored. You also saw the different shapes of the graph, went back and forth from one form of the equation to the other. And those are the skills that you're going to need to do the harder word problems that we're going to cover here in lesson 12. Generally speaking, chapter 2 is a question about polynomials in general. So today we're going to focus on the quadratic, and then whatever we kind of are able to deduce and find out about the characteristics of the quadratic, we're then going to be able to extend it to talk about the characteristics of all polynomials. So to kind of set the scene here, many real-world applications involve finding the maximum or minimum value of a quadratic function. Whenever you see the word maximum or minimum in terms of a quadratic, you're always going to think about the vertex. So when you're being asked to find a max or min, you can either find the vertex using the correct graphing calculator commands and, of course, an appropriate window. If it happens to be a straightforward, short, non-decimal word problem, it might actually be easier to find the vertex by hand. You just have to be careful because remember, finding the vertex in standard form is not the same as finding the vertex in vertex form. Finally, when you're being asked these types of questions, make sure that you read the problem carefully and only give me the answers that I'm asking you for. So sometimes they ask you what gives the maximum or minimum. If they're asking you what gives the maximum or minimum, make sure that your answer is the x value of the vertex. If they're asking you what actually is the maximum or minimum, make sure you're giving the y value of the vertex. Technically, if I ask you for both, it's wrong if you only give me one. And if I ask you for only one and you give me both, it doesn't show me whether or not you actually know the difference. So please make sure you only find for me exactly what I ask for. So we're going to start with number 6, and I started with number 6 because the introductory lesson last night was 1 through 5. So if you did take notes on those examples, you can go ahead and pick right up with example 6. And if you, don't feel like you have to write down all the different words of the word problem, these problems will be available for you to go back and refer to if you need to. So a basketball is thrown from the free throw line from a height of 6 feet. What is the maximum height of the ball if the path of the ball is negative 1/9 x squared plus 2x plus 6? So again, you know that it's a quadratic, of course, because of the squared. Whenever you see that they're asking for the maximum, you know that they're going to be talking about the vertex. Think about what the graph of this would look like. Again, in a couple of minutes, we're going to solve the majority of these questions using the graphing calculator, but this is actually a relatively simple, straightforward one, so I actually think it's easier to do it by hand. If you were to think about what this graph would look like, the fact that the y-intercept is 6 means that you wouldn't actually have a full parabola, you'd only have part of it because it's starting from a y-intercept of 6. As we go through these problems, you do want to think about whether it's a full parabola, meaning it's starting from the ground, or whether it's only part of the parabola, meaning it's starting from some other value. So we are, of course, looking for the vertex, which is right here. Hopefully, based on yesterday's lesson, you will remind yourself that this is in standard form, which means to find a vertex in standard form, you're going to use the equation negative b over 2a. Luckily for us, A, B, C, it's in the right order. So if I want to calculate the vertex, I'm going to do negative 2 over 2 times negative 1/9. Simplify, negative 2 over negative 2/9. Multiply by the reciprocal. You would then, of course, cancel out these 2's. A negative times a negative would, of course, give you a positive 9. So this negative and this negative would, of course, cancel out to be a positive 9. When it says what is the maximum height, remember this is only the x value of the vertex. If you want to actually find the corresponding y value, you're going to head and go back to your equation. Everywhere there's an x, you're going to put in a 9. You're going to very carefully use parentheses. Don't forget about the negatives. And you're going to get a y value of 15. Because they said, what is the maximum height? You're looking for that value of y equals. And because it is a word problem, you should, of course, have a unit. So y equals 15 feet. That is the maximum height of the ball. Here in number 7, a local newspaper has a daily production cost of 55,000 minus 108x plus 0.06x squared, where C is the total cost in dollars and X is the number of newspapers that are printed. How many newspapers should be printed each day to yield a minimum cost? So here's an example of when you're being asked to find a minimum. And again, compared to the previous example, which had a negative A, the fact that there is a positive A means that you are in fact going to be having a quadratic that is facing up. So that should make sense why they're asking you for a minimum, not a maximum. Notice that because this is a problem about cost, you always want to minimize your cost and you always want to maximize your profit or your productivity or your area. So kind of start thinking about the situations where you'd be minimizing versus maximizing. If you take a look at this problem, again, this is a problem that's almost in standard form. The reason why it's not directly in standard form is because of the order. So I would strongly recommend that you begin by rewriting it as follows. Once you rewrite it as follows, again, the time that it would take you to type that in the graphing calculator, and especially since you have that huge number of 55,000, that potentially means you could have a very large window. I actually do think it's easier in this case, again, to just do negative b over 2a. So negative b is going to give you positive 108, 2 times 0.06. Then you're going to go ahead and simplify the bottom. So that would be 108 divided by 0.12. If you then go ahead and divide 108 by 0.12, you're going to get an answer of 900. Because the question said how many newspapers should be printed in order to yield a minimum cost, the X value of the vertex, that actually is your answer. So the answer is 900. And again, 900 what? Newspapers. If you actually wanted to find that minimum cost, you would, of course, plug that 900 in for all the X's, and you'd be able to do that. But as I mentioned earlier, for each of these problems, make sure you're finding no more or no less than what I actually asked you for. Here in number 8, find 2 positive real numbers whose product is a maximum if their sum is 260. You cannot guess, you need to set up and solve an equation. Again, when it comes to tests, when it comes to the AP test next year, you have to show your work if you want full credit. So the truth is you might be able to guess with very little work what the 2 answers are, but you do have to show me that you're able to do so using an equation. So if you're going to set up an equation, you of course have to start with some variables. So I'm going to go ahead and start with an X, and that's going to be the first number. So again, we're adding up 2 numbers, so I'm going to go ahead and make that my first positive real number. Then when you go to set up your second number, you can call it a Y if you want to. But when you go to solve the equation, you cannot have just an X and a Y. That is too many variables. You have to have just one variable total. So in order to do that, you have to think about what is the relationship between X and Y. The fact that they're telling you that your 2 positive real numbers have a sum of 260, that is telling you that if you add X to Y, you're going to get a sum of 260, which means to get the Y by itself, you're going to subtract the X. And so you're going to call your second variable 260 minus X. So 260 minus X will give me the second number. X will give me the first number. I am trying to find their product. So of course that product would mean that you multiply them together. So if you multiply them together, that would be X times 260 minus X. That's an example of a quadratic in factored form. If you remember how to find the vertex in factored form, feel free. If you don't remember, go ahead and distribute. When I distribute, I'm going to get a 260x and a negative x squared. And I'm just going to go ahead and cut out the middleman and jump right to standard form. Again, this is really a relatively simple equation. So if I'm trying to find the maximum product here, again, that has to do with the vertex. So I'm going to do negative b, which would be negative 260, over 2 times negative 1. That's going to give me 260 over 2, which means that my first number is going to be positive 130. That's good news because, again, it had to be a positive real number. Then it asks for what are the two numbers, which means you now have to plug this back in and find what the second number is. The second number is 260 minus 130, and it turns out that the second number is also 130. And if you kind of think about that for a second, that should make sense. The closer that the numbers are getting to each other means that they're both large, which means they are going to have that maximum product. But again, you can't just guess. Not all problems are going to be this simple where their relationship is simply a sum. It's more likely to be some harder relationship where it's twice as many as 4 as much. And so you're going to have to definitely solve an equation, not just be able to guess. And again, here, what are the two positive real numbers, 130 and 130? If you actually wanted to find that product, you could multiply them together. But again, that's not what they're asking you for here. Number 9, a fence is to be built to form a rectangular corral along the side of a barn. Make sure that you're reading here. The sign of the barn does not need any fencing. If 120 feet of fencing are available, what are the dimensions of the corral of maximum area? So again, you're being asked for the dimensions and you're looking for a maximum area, which of course implies a vertex. And yet again, you're not allowed to just guess, but you need to go ahead and set up and solve an equation. So I'm going to go ahead and start by drawing a picture, which is usually the best thing to do whenever you have these types of problems. So notice, first of all, that you have a barn and you are building your fence next to the barn. So you don't have to build a fence where the barn is because that's going to go ahead and be one of the sides. So instead, you are trying to go ahead and build these 3 sides. So again, you need to go ahead and assign some variables. I don't know how long this side of the barn should be, so I'm going to go ahead and call it X. Whatever I make that side of the barn, this has to be the same, or that would be a pretty terrible barn. Again, it does say here it has to be rectangular. So of course, those 2 parallel sides have to be equal. Then think about where the fencing is coming from. So if you have 120 feet of fencing, what that is essentially saying is that the perimeter of your corral has 120 feet. You need to be able to divide that up. So what you're saying is that in order to solve for the second side, you will have had 120 feet. Then you will have subtracted the X from each of those sides, which means that the length of the long side is however much you have left, which would be 120 minus 2x. Again, the only way these problems are going to work is if you have just one variable. So that's why I need to go ahead and resolve a y to be 120 minus 2x. It's not going to work otherwise. This is an area problem. So an area is, of course, length times width, which would be x times 120 minus 2x. Go ahead and distribute. And again, when I distribute, I'm just going to save a step by writing it immediately into standard form. So negative 2x squared plus 120x. Negative b over 2a is going to give me negative 120 over negative 40, which means that x is going to be 30. They wanted to know what are the dimensions. So x, these have a distance of 30 feet. In order to find the other dimension, you're going to plug 30 in for this x right here. That's going to give you 120 minus 60, which is going to be 60. So your answer here, what are the dimensions? Your dimensions are 30 feet by 60 feet. And again, if you actually wanted to find what was the area of that corral, you could go ahead and just multiply those 2 things together. Obviously, it should make sense here to get only positive answers. If you're building a barn with a negative side length, then I don't think that's going to work out for you. So kind of keep common sense in mind as you work through these problems. This last problem here has multiple parts, and we are going to do it using the graphing calculator because of the fact that these numbers are really not so nice. So here is where you should have your graphing calculators. And again, I'm going to be going through this video with you. So I'm going to be reminding you of how to do all these different operations. But basically, Johnny is throwing a shot put. The path of his throw is given by the following. X is the horizontal distance traveled by the shot put, and Y is the vertical distance, and both of them are in feet. So here's a little picture. You can see where Johnny is starting to throw from. What you can't see for sure is exactly how high it gets. And then you're going to want to eventually, find out how far he can throw it. So starting off, from what height did he throw the shot put from? Luckily for us, the starting height is, of course, the y-intercept, which means he is throwing it from 5.5 feet. No work required. For the second question, what is the maximum height of the shot put? So again, we now want to go through this problem using all the different commands to make sure that you know how to find the vertex exactly. And again, you're not allowed to just guess. So go ahead and take out your graphing calculators. Go into the y equals. Make sure that any of your plot 1, 2, or 3s, make sure those are deselected. Those should be off. Go ahead and very carefully type this equation into the y equals. After you've typed that equation into the y equals, we want to make sure that we can see it. So you're going to have to go ahead and pull up an appropriate window. When you go to choose an appropriate window, you always want to have at least a little bit of negatives. So I would make my x minimum and my y minimum like -10. You want to at least be able to see a little bit of the negative, even though your answers can't actually be negative. Then in terms of the biggest X value, well, if you take a look here, about halfway is, 20 something. So how far he can throw it should be about double that. So you want to, again, err on the side of caution. So maybe you're going to make your biggest X about 60 just to make sure that you can see the entire parabola. When it comes to the y values, you can kind of see just from the graph here approximately how high it looks to be going. But again, if you wanted to keep it the same, you could also choose a y maximum of 60. Either way, when you press graph, you have to make sure you can see the entire quadratic, where it starts, where it ends, and its highest point, which is, of course, the vertex. Once you have the picture in front of you, we're going to go ahead and find this point right here using the buttons on the graphing calculator. So you're going to go ahead and press second trace. That's going to bring up the calculate menu. Because of the fact that the quadratic is upside down, you're going to choose maximum. You should have a little blinking cursor close to where the vertex is. The left bound means you have to go ahead and scroll slightly to the left of where you think the maximum is. Then the right bound means you have to scroll slightly to the right of where you think the maximum is. It's going to ask you to guess, which you can do if you want to. But if you go ahead and press enter one more time, it'll actually tell you what that ordered pair is. And I don't really care too much how you round for now, but it should be 20.7, comma 15.9. And again, if you have slightly different decimals based on your graphing calculator version, that's fine. Because they're asking what is the maximum height, that means they want this y value right here. So that would be 15.9 feet. In the next question, how far does the shot put go? So that means it's going to eventually land on the ground at some distance over here. We can clearly see that it is some distance bigger than 30, but we do have to be able to find it for sure. If we were to go ahead and continue the graph, we would essentially be looking for where it intersected the x-axis, and your graphing calculator calls that a 0. So you're going to, again, do second trace. That's going to bring up your calculate menu. You're going to choose the 0. Here's where you have to be careful, because technically there's a second 0, which would be over here in the negative region. Because this is a word problem, that negative answer doesn't mean anything. So you have to make sure that you choose the positive one. So as you bring up your 0, you're going to, again, left bound. You're going to scroll closer and closer and closer to the x-intercept, but make sure that you're on the left of it, which means you're above the x-axis. Then hit enter. In order to make it a right bound, you have to be to the right of where it is, which means you have to be underneath. Again, guess if you're fancy. If not, you can just go ahead and give me the value, which is approximately 46.4. If you see something with an E and then a negative number, that is an extremely small number in scientific notation, which is basically just 0, which you obviously know that it should be since it's the x-intercept. So how far did the shot put go? That is 46.4 feet. Again, just make sure you're finding exactly what I asked for. And last but not least, what is the real world domain and range of this shot put? So that means in reality, ignoring the fact that the graph on your calculator goes on forever, where does the horizontal distance start and where does it end? Well, you're throwing it from x equals 0 to its furthest location, which would be 46.4, brackets for both, since you're actually going to get there. Then for your range, the lowest the height is going to be is 0 when it hits the ground, and the highest it's going to be is the maximum height, which would be 15.9. And again, both of those should have brackets. So I think the majority of the problems in the homework tonight do want you to use the graphing calculator. Again, because of the format of the year, you're always going to have that as an option, but I do think it's good that you're able to do it both ways. One final problem for today, and this is actually just a preview of the lesson that we're going to do tomorrow. Tomorrow, we're actually going to kind of start talking about, or actually not tomorrow, the next day, excuse me. We're going to kind of start talking about where does the difference quotient come into this stuff and where does it kind of have to do with calculus. So as a quick reminder, the difference quotient is here, f of x plus h minus f of x divided by h. Here is a function. I have to give you both of those. If I ask you to find the difference quotient for this quadratic, for f of x plus h, that means go to the f function. Everywhere there's an x, you're going to put an x plus h. So that means you're going to start with x plus h, the whole quantity squared, plus 5 times x plus h plus 6. That's just f of x plus h. Then you're going to subtract the entire f function, which is x squared plus 5x plus 6. That's still technically all over h, but I'm going to leave that out for a minute just while I simplify. So x plus h squared, that's a FOIL. X times x is x squared. X times h is xh, and there's going to be 2 of them for outers and inners, plus h squared, 5x, 5h plus 6, minus x squared plus 5x plus 6. And again, technically, this is all still over h. You're going to go ahead and start simplifying, and good things should happen. Sorry, I forgot to actually distribute my subtractions there. So it should be a negative x squared, a negative 5x, and a negative 6. The reason why that's so important is because lots of things should cancel. This x squared cancels with this x squared, this positive 5x with this negative 5x, this negative 6 with this positive 6. Notice that you're only left with things in the top that have an h. So just to simplify that, on the next screen, you're going to have 2xh plus 5h plus h squared divided by h. Luckily for us, we can reduce an h from everybody. So this h is gone with this h and one of these h's, which means my final answer is 2x plus 5 plus h. We had just one of these on our first test of the year, which I would say maybe a third of us were not able to do. This is going to become really important, again, not tomorrow, but the next day. So I thought it was kind of good just to go ahead and set the scene. Here's homework 12. This is your homework tonight. Again, it's only a handful of word problems, and then pay special attention to 86. So 86 is a quadratic regression. Remember last chapter, we did linear regressions. So you're going to have to be able to duplicate the steps, but for a quadratic problem. So go back and review. How do you turn your stat plot on? How do you enter the data? How do you calculate the quadratic regression? You're going to have to be able to find regressions for all different kinds of functions. So here's just one asking you for the quadratic. So thanks very much for tuning in, guys, and we will catch you next time.